we are studying another experiment, and the name of this experiment is determination of specific gravity of soil. So, specific gravity is the soil is the ratio of a given sample of given in the air and in the equal volume of distilled water. So, to find out the specific gravity, we have to take some samples and some apparatus. Now we are displaying some apparatus. Like you can see, there is a balancing machine here, in which we can take the soil weight or the soil sample weight with distilled water or without distilled water. And this is the distilled water in a beaker. And here you can see a thermometer which is inserted in the water, and we have to take the temperature of room temperature by using this temperature. And now you can see the volumetric flux, and we have to take this volumetric flux and we have to take all of these samples in here, and we are using this volumetric flux to take the specific gravity of the soil sample. And to input or to insert the soil sample in the volumetric flux, we use some funnel, and we can see some different sizes of funnel. And here is dropper where we can use this dropper to drop the water. And this is the soil sample, and this soil sample is a dried soil sample, and we are drying this soil sample by using a oven. You can see the oven next here. This is the oven, and by using this oven, we are drying our sample to get the sample to get the actual sample for our experiment. So we are starting our experiment right now. First of all, we have to take the volumetric flux on the weight machine, and the weight machine shows the weight of the volumetric flux is 175.36. This is in milligram. And now we are taking the sample by using the funnel into the volumetric flux. You can see how the sample is inserting into the flux, and there is no limit actually right now to take the sample. We have to take a minimum amount of sample, but we can get the weight after taking another weight of the volumetric flux plus soil sample, and after reducing the previous weight, we can get the weight of the soil sample. So we are finishing the inserting process. Now we have to insert more soil sample to fill up in a desired amount. So this is another insertion. This is actually a continuous process, and by using by continuation, we can fill up the flux in a desired amount. And here you can see. Okay, finally we are finishing the inserting process. Now taking the value. Taking the value of the volumetric flux having the dried soil sample in it. So the balancing machine shows the weight is 420.30 gram, and if we are reducing with the previous amount or previous weight, we can find the soil sample weight. Now we are filling this volumetric flux with water. You can see there is water pouring from the beaker into the volumetric flux. Okay. Again, we have to take the weight of the volumetric flux. Now we are inserting. We are having the volumetric flux, having the soil sample, and also the water, and we are shaping in a proper manner to get proper mixing in the volumetric flux. So this is a critical process actually in the shaking in shaking. it will take time to get the proper mixing. And yes, now we are getting the proper mixing, but there are some soil particles which is in the surface of the volumetric glass. So we also have to take all of these samples by using the water. Now you can see there is a difference of the funnel. Now we are using the smallest funnel, and before that we are using the largest funnel. So now we are taking the value of the volumetric glass. We can get the result of the volumetric glass, and after reducing the result we can find out the amount of water which it takes. The amount is 814.37 gram. So we have to take these steps by 3 times or 4 times to get the proper result or to get the accurate result. After calculating these results, we can get the specific gravity of the soil sample. Thank you. Okay, this is the next step for our specific gravity. In the previous step, we saw that we got results of the volumetric glass having dry soil and filling up with the water. Now we are taking the water in the beaker after cleaning that in the previous process. Now we are taking the weight in the volumetric glass. So our balancing machine says that this is 681.139, and you have to careful about the water mark, because in a beaker volumetric glass there is a mark where which indicates that you have to take the water up to this mark. So this is very careful, and whenever you didn't get the mark, so you have to use the dropper to get the desired mark or to get the desired water content. And we are getting the room temperature by using the temperature machine, and this is 22 degrees Celsius right now in this experiment room or lab room. So after calculating all of these values, we can get the specific gravity of the soil sample, and this is the finishing, and this is the end of this experiment. Thank you.
This is the conclusion part of determination of the specific gravity of soil. You can see the equation is given here, where Gs is the specific gravity of the soil, and you can also see some notations like Ws, W3, W4, and the description of Ws, W3, W4 is given here. There is also another portion is Gt. Gt means a specific gravity of the distilled water at temperature T degrees Celsius. So it depends on the room temperature. We previously determined the room temperature, and by using that temperature, there was a chart from where we can get the value of Gt. This is a constant value. These are the objective materials, equipment, and the experimental procedure of this experiment. This is the calculation table. In that table, you can find the value of W1, W2, W3, W4, T degrees Celsius, that is the temperature, the weight of the solids, specific gravity finally. So, all of these values are taken from the video or from the experiment, like the weight of the flask was 175.36 gram. Weight of the flask plus dry soil was 420.3 gram. Simultaneously, weight of the flask plus dry soil plus water was 814.37 gram. If we deduce these weight of the flask plus dry soil and weight of the flask plus dry soil plus water, then you can get the amount of water which is given here. And Simultaneously, you can find the weight of the solid by reducing from W2 to W1. That means this 420 to 145.36. The value is 244.94. It indicates that we pour 244.94 grams of soil in the flask. Here is also the calculation given here. The temperature was 25 degrees Celsius. Depends on the temperature, the value of GT is 0.9974. After calculating all of these in the equations, you can find the specific gravity, that means the GS, and here the value of the GS is 2.2.